Okay, so in this video, I'm going to be showing you all how to make best fit lines, otherwise known as trend lines, with data in Microsoft Excel, Google Sheets, and Desmos as well. So you'll have different ways of doing it. They're all slightly different, so I'm going to go through each of them real quick here. So what I've got here is a browser, and I'm going to browse to my Google Sheets. If you have Google Drive or whatever, you go to Google Sheets, you can open this blank spreadsheet. And so I'm just going to make up some data. So usually when we are doing a physics lab, we measure a couple different things, and then we're looking for a relationship between them. So I need to make up some data. So I'm going to have some y-axis data, and these are just some numbers of something that I've measured. And this is the data on our x-axis. And so, for example, the y-axis data could be a force, the x-axis data could be a velocity or acceleration or something like that. I'm going to make those bold just to make them stand out. So those are the headers. Okay, so now I need just some plain old, some numbers to graph. So let's just say I made my first measurement at an x-axis value of 0.01, and then the next one is 0.02, and so on. So I want to measure whatever it is on the x-axis at regular intervals, and I'm just going to use this pull-down thing to fill out. So 0.1 is up to looks like 0.23 here. Doesn't matter. And then let's say we've at each of those x-axis values, we've measured something on the y-axis that we're going to graph on the y-axis, and I want that to just be kind of random. So I'm going to make it equal to the value in B2. I'm just making up data here, so I'm going to take it. Make it equal to the value in B2. I'll multiply it by 5 just to make it a little bit different, and then I'll multiply it by a random number between 0 and 1. So this function in Excel gives me a random number between 0 and 1, and what that'll do is just kind of scatter the data around so it's not this perfect line, so it looks more like realistic data. So in this case, it came out to 0.017, and then I'm going to use this to copy that same formula down. And so you can see now that I've got a bunch of different values. And in general, they should kind of go up, but they're going to be scattered around, and we'll see what that looks like when we graph it. So the first thing we want to do is graph this. So I'm going to let's come over here and make some room. So I'm going to insert a chart, and for our purposes in a physics lab, we're generally going to be doing a scatter graph because we want to just plot a bunch of points separately with their x and y coordinates. So there's our x-axis. We're going to add a series of data, so we're going to select a range of data. So actually first let me add x-axis data. So the x-axis data is the stuff that's going to go on the horizontal axis. So I need to select the data there. So I'm going to do shift click here to select that range, and then I'll hit OK. And then I want to add a series of data, meaning the y-axis values that go along with that x-axis. So I'm going to add a series. I'm going to select here. Oops. So I'm going to add a series, and then I'll click this to let me select it on the chart. So I'll do the shift click here, and then OK. And then that's my data, right? Now there's a couple things we want to do with this first before we get to our main goal. One thing is you'll notice that this is 0 to 0.2. This is, okay, so the axis really does have its origin at 0, 0, so that works well. If I double click on this data range, then I'll be able to add a trend line. Now you can see that this is pretty scattered around data. I just kind of made it up, but it does kind of have an upward trend. So first we have to decide, do we think this is a linear relationship? Meaning, do we think it's a y equals mx plus b general type thing? If it is, then I can use that formula for my trend line. So what Excel refers to as a fit is this trend line thing. So I'll click that. And then automatically it's going to assume that it's a linear. It may not always be linear. It might be polynomial or exponential or something, but the most common one is linear. So when I add trend line, it's going to automatically click linear. I can change the color or whatever. And then I can do some other formatting stuff, make the line thicker or whatever. Generally, we want to show the equation. So we want to label with the equation. So you can see with this set of data, it has a slope of, this is y equals mx plus b. So it's going to have a slope of 2.19, whatever that means in the context of our experiment. And then 0.0673 is our y-intercept. So that's how we do a linear fit in Excel. If we want to do a quadratic fit or something like that, we can do a polynomial. Secondary polynomial would be a quadratic. So you can see that that's going to give us a different fit. but most commonly we're going to do a linear fit. And so if we want to know the slope, we've got it right there. If we want to know the y-intercept, we've got it right there. So that's basically it for that. So now let's move on to, that's Google Sheets, so let's move on to Excel. So I'm going to do Excel, and you'll see that this is very different, very similar actually, and so I'm going to run through it pretty quickly. So the first thing I'm going to do is select all this data, Control C to copy it, and then come over here to Excel and press Control V to paste it in there. So now I've got that same data, and so how would I do this in Excel? I would do Insert, where is it? Oh, Recommended Charts. Okay, so here you can see this icon here. We just drop down here. We're going to want a scatter graph with no lines or anything connecting the points. We just want a regular scatter graph. And then when we double click on it, we're going to click on the plus sign here. Oh, excuse me. We're going to click, we're going to double click on this, and then it'll open up a formatting menu, and then up here we can do select data. And so we're going to add, well, first of all, we can give it a name, so this name doesn't matter, I'll just call it my data. And the X values are these values, shift click. The Y values, shift click to select those. And then we can see pretty much the same behavior that we had in Google Sheets. And so how do we do a fit here? We also do a so here it's a little bit different. We right click on one of the data points, and then we can add a trend line, and it's again very similar options. So it's gonna, the first assumption is that we want a linear fit line, and then the other important thing is that we want to display the equation on the chart, and you can see here that we should get the same slope and intercept that we got with Google Sheets. 2.19 for the slope, 0.0673 for the y-intercept. And then the last way we want to do this is probably my favorite way, which is Desmos. So if you've used Desmos to graph things, then you'll know that you can copy and paste data. Once you've made a table, it doesn't matter if you entered the values in Desmos, or if you enter the values in Excel or Google Sheets or whatever. Once I go to my spreadsheet here, I can Control C to select this data, and then I'll Control V here, and it'll paste it in here. And so you can see already, when I zoom in here, we've got that data right there. So I can kind of zoom into the graph a little bit, and then hopefully you know how to do graph titles and axis titles and things like that. In Desmos, you can Google search those if you want. But what we want to do here is a fit. So notice here that it referred to the y-axis values as y1 and the x-axis values as x1. Well, that's actually backwards of what we want, isn't it? So we want the x-axis values to be the 0.01, 0.02. So because of this, it kind of shifted things a little bit. So let me undo that and show you how we can fix that. Okay. So I want the y-axis data to be to the right. So I'm just going to copy paste that over here, and then I will copy paste this into Desmos. So there we go. So now the x values are my regular increment values, and my y values are the resulting values. So let's zoom in. And then how do we do a fit? Now we already know what the fit equation should be if it's a linear fit. So it's just a matter of telling Desmos to do it. So we're going to come down here, we're going to create a new little entry here, and then we want y equals mx plus b. Now in this case, the y values are data points, and they're called y1, that column. So I'm going to do y underscore 1 to put the subscript, and notice that it identifies that as a 23 element list of numbers. We want to identify that as a line, meaning m times x1, so the x values are these x1 values, mx plus b. And m and b are unknown values at this point. It's going to use the numbers to determine what m and b need to be in order to make the data fit the best. And in Desmos, the way we tell it that it's doing a fit is we use a tilde. This is the button shift, and the button right next to the number 1 on your keyboard gives you this. So it's not an equal sign, it's telling it this is, I'm telling you to do a fit for an equation that looks like this, which is a linear fit, and it's going to have to find a slope and an intercept that makes it work best for this data. And again, you can see that the parameters it gave us are the same exact parameters that Excel and Google Sheets gave us, 2.19 for the slope. And we can do this for anything. Like if I wanted to make this a quadratic, I just type a quadratic equation in the variable x1, which is ax squared plus bx1 plus a constant c. So I can also fit this with a quadratic, and it'll give me the three parameters that I left free in this equation. But of course, most of the time we're doing, and again, notice that this is even nicer than Google Sheets because we can type any formula that we want. But in this case, we just want a linear formula, so I'm going to backtrack here and make it a mx plus b again. So that's how we do a linear fit, and then we can add any kinds of, if we want to add an equation here on the graph, how do we do that? Well, we can make up a point by just typing an ordered pair 0, 0, right? And notice that that puts a point right there. And we can give it a label, but actually instead of doing the label, I just want to make up my own label, and I want the label to be this equation. So the way we're going to do that is get this thing, and then we can make up, you don't want the label. Okay, yeah, here's how we can type our own label. So we want the label to be y equals 2.19, which is the slope, times x plus 0.067. So notice that this allows me to make up my own label. And if we click this gear, we click the gear and then we click on this, we can make it able to drag around. So now I can put that wherever I want. So remember, that's just a label that's going with the line to tell the reader of the line that that's the equation for that line. I can also be a little bit fancier, and I can make it match the line, and I can take away the point, so there's just the line equation itself. And then if you want to put this, for example, in a report, you can do this button, export an image, and then you can download the image as long as you get everything formatted the way you want. You can download the image and put it in your report. So that's all. That's how you make a fit using Google Sheets, Excel, or Desmos.